哇，还有 transcript 哎，嗨，Oh my God，诶，诶，很强哎，强。All right, so let's starting our lecture. Right, so start my wait a minute. Okay, sorry, I cannot. 哦，每次都这样，烦哦。Sorry, I cannot project my project my iPad onto my screen. NYCU NYCU，为什么不行？好，等我一下哦。现在就有了。好，很好。OK，真的是。All right, so always be like that. 不对，不是这个。Hey, hey, hey. All right, so let's summarize what we give you a quick, briefly review for the last week. All right, so this chapter talk about the talk about the um, axial loaded members, and also we talk about the displacement and load relationship, which is delta equal to PL divided by EA, right? And also, um, we know that we can use the geometry condition to help us to determine, well, geometry to help us determine the displacement. Okay, so for example, you know that the displacement for one point, and then you can obtain the rest of the point, and then you use the rest of point displacement to determine the force act on subject to the material. Okay, act on the material, and also we talk about the bar with different cross-section and intermediate axial loads. So easy, because the concept is that all you need to do is cut the section, okay? And then you can get the internal force in that particular section. And then you determine the displacement of that section, and you do 1, 2, 3, or 4 or 5 section, and then you sum it up together, you can get the total displacement. All right. So yeah, similarly, if you have an infinitesimally increased section, you end up with, you can transform the summation into integration. All right. So the most important things for this type of problem is that we are going to determine the function of all these material properties and also the load conditions. And then we can do the integration. All right. And then yesterday, no, sorry. Last week, we talked about this problem. And then there are two components in this system. And the yellow part is rigid, and then we has two force. And then the question is that what is delta C? So delta C, firstly, we need to obtain the force at the point B, right? So for example, because everything in this system is balanced and in equilibrium, so which is not move stable. So we can cut it and then separate two component and calculate the force individually. So you can determine the force balance in this one first component. And you see that after you've done the force balance, you know the PB is downward, all right? And then the most important part is that because this is downward at B point, so the opposite side, the second component, you can see that B and B should be overlap and overlap. So which means that the force in these 2 points should be cancel each other and become an internal force that you cannot see it in a real system, right? So you say, okay, we determine B downward in component 1, so which indicate the component 2 has an opposite direction but the same value force B. So you can have the upward PB here, and then which means that you can determine the reaction force in the second component. All right. So after that, you've done these two steps, and then we're going to determine the total displacement. So we need to cut the first section and cut second section, and then no matter what upper part you are going to miss, neglect, or upper part, lower part you want to neglect, they are all okay. Okay, both are okay. So here I give you an example. Choose upper part or upper direction, upper part of the component, and lower part and at the lower at the components. Okay, so you see N1 equal to RA, N2 equal to P1, and also you can notice that N1 and RA give the first section compression, and N2 and P1 give the second lower part of the component tensile. Okay, so yeah, so now we stop here, right? Now we continue. So delta C is delta C equal to delta C equal to a minute. Delta C equal to 2.3 times 10 to 3 times 500 times 10 to minus 3. Okay, this is PL divided by EA, right? PL 12.3. What is 12.3? 12.3 is this one. Okay. And L is 500, and 200 times 10 to 9, which is E. A is 160 times 10 to minus 6. Okay, this is the first part. And also, this is compression. Okay, this is a compression. You can see that here. Okay, and then the second part is that you are going to have okay. You're going to have a second part, and okay, which is what is 110? Is that correct? No. The force. What is the force? P1. Oh, 10. 10. 10 times 10 to 3. I just want to tell you the story that I just cannot recognize my writing in my own script on my iPad. Interesting. 200 times 10 to 9, 100 times 10 to minus 6. And then, because this is the bottom part of it, and it has tensile, okay? And finally, minus 1.92 times 10 to minus 4 plus, sorry, I should move a little bit here, and 3.75 times 10 to minus 4 m. So we finally get 0.183 millimeter. Okay, that's it. So maybe you can notice that PL delta equal to PL divided by EA. This is a good equation. However, you need to note that the two components, the two sections may not necessarily all tensile. Okay, they might one of them become compression, one of them become tensile. Okay, so this is you need to cut and then know the internal force in it, and then you know this is compression or tensile. I think this is quite important. All right. Right. I just want, okay, so this is done, okay, finished. I hope you can write down and take a note. And during that time, I can share some story, maybe in Chinese first. 总之就是我刚刚就发现，哎，我这个数字我自己在写什么都不知道，然后哎，我就想说这个，尤其是这个，就我在里面呢，哈，这个10我写的不是很清楚。那这时候我跟大家分享一下，就是我在演讲的准备上。我以前第一次上台演讲的时候，我就英文演讲的时候，我就把讲稿都打好咯，然后我就印出来哦，然后练习了几次，反正我想说我不用背，我只要看着讲稿就好了。结果我发现我上了台以后，非常的紧张，我没有办法，因为我不是就这样一个一个字念，我还是会弄投影片啊或什么什么之类的。所以当我一离开我的稿子以后，我就找不到我自己现在到哪里去了。所以那场演讲非常的糟，好，就是我第一次上台应用演讲。后来我发现一件事情，就是千万不要相信自己的，就是千万不去背你的演讲稿。你不要以为说你可以看演讲稿，你就可以给一个完美的演讲，不可能的。你一定是要背的，或者是说你已经确定知道自己要讲什么，你才可能可以讲得好。那这是我从以前到现在的经验哦，就是然后多练习哦。那所以说，真的是这样子，所以不要过度依赖讲稿。就这样啊。然后英文讲的话，就是 please just memorize what you are going to say in your speech. Okay, I just sharing my story is that first time when I first time when I'm going to give the English speech in a conference around 20 years ago, 20 years ago. And I first on the stage and I prepare all my script and print it out as A4 papers. And I noticed that I cannot read on the stage. I cannot find where should I say. Okay, I missed the spot in the A4 paper. So this is it was a really bad speech or conference talk. So then I noticed that I need to practice and memorize all the words, sentence I need to talk about. And then if I cannot memorize, how can I do? I just put the keywords on the PowerPoint or on the slides, and then you can see the keynotes and know what exactly you are going to say. All right， 我刚刚最后没讲到这个，就如果你背不起来，那你就把你的关键字放在你的投影片上。那你只要看到那关键字，你就我知道讲这一段，我知道讲这个，大概是这样子。所以虽然我的 iPad 里面有小抄，但这个小抄是我在抄数学，我不会在上面想说我要讲什么。所以其实这大概是，然后我在上面我会标注说我要先讲什么，再讲什么，再讲什么，第一个、第二个、第三个。那这可能也是但是我绝对不会写说第一个要讲this is a pen， 类似这样讲，不会我就讲这第一个好，我开始讲，第二个我开始讲，那我就不用去思考哪一个逻辑要先讲。所以这一张投影片放上去，你就会觉得说我要先讲，如果没有标示顺序的话，我就不知道要讲哪一个，你会很紧张但是你数字都标示出来的话，你就 OK 了。这样，即便我讲了这么多年了，11年了，12年了，我还是需要小抄。所以说，对啊，真的是要演讲就是一个或是上台演讲算是一个修炼了一生都要一直去精心的雕琢它，精进它。Just and it's very difficult to have a speech on the stage, and then all you need to do is prepare. Okay, just prepare. Right, next one. Here is the continuous changing cross section. Okay, and it need us to find a delta elongation of the bar. Okay, the blue part. So you see bar AB has a force P at the beginning, at the left hand side, okay? And then it is a circle shape of the cross section. And then we are going to find the delta. What is delta? Delta is summation mx dx divided by ex ax. All right. So what is it? This is nx function. It's actually easy because it's p. Only one p constant p at the left hand side. Okay, so your nx is quite simple. It not varied with x, so it's okay. All the section you cut, you will get p, okay, in the internal force, no problem. So nx easy. How about e? E is the same material, so it is also a constant, no problem. All right, so all you need to worry about is ax. So how can we find the ax? Okay, so we need to, firstly, we need to find the relationship between a and x, okay, which means a of x, or we can say further, which means dx. What is d? D is the diameter. All right, so we need to find the dx. All right, dx. And please note that this d of x is not dx. The dx is the gradual small change along x-axis. along x-axis. Dx is small change, but the d of x is that the diameter is a function of x. All right, these two are different. Please careful about this. So let's take a look. How can we get a d of x? Right. So let's take a look. So we can use a similar triangle to find the dx and the x relationship. So for example, if you make the A and B bar into a cone, maybe, okay, cone. So you can elongate them, extend the boundary, and it will finally focus on one point O. Okay, so we treat that as a origin. All right, and then we notice that these shape, these shape. Show. Okay, and that shape can be treated as a similar triangle. And you see, this is dA, and this is LA, this is dx, d of x at the x direction. All right, so you can see these two relationship. So d of x with the ratio between dA equal to the x length divided by LA. Okay, so your dx is x dA divided by LA. All right, so your AX equal to pi d square x, d square of x divided by 4, which is pi dA square x square divided by 4LA2. All right. So you successfully obtain the relationship between A and X. So you can substitute this A into this A. All right. Then all important things come in. Right. So now P E and pi dA squared x squared 4LA squared. All right. Okay. And dx. The problem is that what is the upper limit and lower limit? What is that? So 0 to LB, is that correct? No, it should be LA to LB, because this point is imaginary. Okay, you made it up. So LA is actually, you don't know the value. Okay, but let's dealing with that later. All right, LA, LB. So actual value, actual material start from LA to LB in this X system. The X origins O here, LA, LB. And LA minus LB, sorry, LB minus LA is L. You know L, but you don't know LA and LB, right? So don't worry, let's continue. Firstly, you can taking the constant out of the integration symbol, pi e dA squared. LB, LA, 1 over x squared dx. Okay? And then, because this is too long, I don't want to write it anymore. So can I just simply make it C? C, okay? 1 divided by LA minus 1 divided by LB. All right, so this is the result. This is a result. And it's give us CL divided by LA, LB. Okay. And let's do further. 4PL. So I make a C back, all right? Pi e dA squared. And LA divided by LB. Okay? And I will give it a blue mark. And blue mark will be used later. All right. And we notice that 4PL divided by pi e dA squared. So what is LA over LB? What is LA over LB? Again, what's that? It's called similar triangle, right? LA and LB is ratio equal to dA over dB, right? Luckily, so dA over dB. So we don't know LA, LB is okay. We know the ratio. Their ratio should be equal to dA over dB, and both of them are known. Okay, so 4PL divided by pi e dA dB. Okay, so this is the answer. If you make a point load P on the left-hand side, and then you have a gradually change of the, not yet, something there, all right? Yeah, so how about that? I'm going to ask you to do the check, all right? Check when dA equal to dB equal to D. What will it be? What will it be? Okay. Anyone want to substitute the D into this and then give me the answer? What is that? Please. Sorry. EA, right? So you get exactly. Very nice. After you PL divide by EA, you can check that. This is a special case. dA equal to dB is the special case that we learn, right? So dA equal to dB, substitute that into the formulation. You can get exactly the same formula, and which tell us this is correct answer. Very good. So please tell me your number. 111. 613. 034. 24. Good. Okay. Very good. Yeah, that's it. So I hope you can understand what I'm talking about here, and then I can share a small story when you taking note. In Chinese first, all right. 就我在美国的时候或英国的时候啊，在念书的时候，那时候有一个麻烦的事情，就是你要在那边办电话号码，然后你就常常会打客服 ，OK， 然后打电话过去，然后他就会问，他会叫你讲你一堆所有的资讯，什么 Social Security Number 啦，或者是你的 email 啊，然后你的电话啊什么的啊，哦，超多。所以我每一次要讲电话之前，当然有几次就是一开始去讲，就以为自己可以讲就讲，这个完全不能讲，我都是做好完全的准备，就是我要先讲什么，Hello，my name is Nien-Ti Tsou，然后 Nien-Ti Tsou 怎么，他一定不会拼嘛，我要说 Nienti Tsou，他也听不懂我在讲什么，所以你要说 N for number，I for India，E for English，N for number。所以我都要把它写好，你知道吗？所以我以前小时候在打电话的时候，我都要把它写好。然后电话号码我也把它写好。然后通常 zero 不会讲 zero，会讲 O。那如果你今天有3个1，你就会讲 triple one，或是反正就类似这样。然后 double O， 就是你会就是再多讲几次以后，他们也是会跟你讲一些号码，叫你把它记下来。哦，那个就是听力练习那个把它写下来。那所以非常的辛苦。那当然这些准备好就还好了哈。所以我已经我在英国养成习惯，就是我每次打电话之前，我都会把我要讲的东西都写清楚，然后会有不同的 part。当他讲到这个话题的时候，我就要到使用这个 part，然后这个使用这个 part，这个使用这样，然后讲完以后啊，这张纸就可以丢掉了，像类似像这样子。那然后最麻烦的是什么，你知道吗？我那时候的客服蛮多不是英国人或是美国人的，他们那时候都是连接到外地去，所以那个当然我就不想说什么国家了哈，你自己猜哈。但是这样不太好，但基本上就是其他的国家的人在帮他讲英文，超难懂超难懂，那个 accent 真的是那个语调真的是完全听不懂，所以到最后啊我就是有时候讲到后来就是哇，我听不懂这个人我就把他挂掉，然后我再打一次，我就会换到下一个客服，另外一个客服人员所以有时候你必须要看运气，遇到就是好的或者你听得懂的客服人员。那你知道那时候我有一个电话，当我要离开英国的时候，我要把英国的电话要把它关掉，对不对那你知道他要关掉的时候，他都会非常不开心，他都会无所不用其极叫你不要关，把你那个号码留下来。所以我跟他讲说我要关，然后他就说你要不要再考虑看看，我可以给你优惠。我说我要关，然后就说那你要不要考虑转给你的亲朋好友？我说我要关。然后说，如果再这样的话，我可以给你个人这样。他就一直讲了3、4次，我就说我不要，我要关。然后他才好吧，就是我跟他熬超久，然后有几个我在猜，他可能就是从某一个客服人员手中丧失一个号码，那个人会被扣钱的感觉。好，所以我那时候花了非常非常多的时间去把我英国的电话把它暂停掉。那在美国的话，我是买预付卡，所以就没有那么麻烦的事情。但是美国的预付卡的话，你就要没事就要去 top up。哎，你知道 top up 什么意思吗？储值的意思我一开始去的时候，我就想说我要 save money，就很逊。但是他们有很多奇怪的字，跟你都没想过这样，所以还蛮有趣的。I just want to say that I need to prepare a lot of things when I talk talk on the phone. Okay, in a board in the UK or in the US, because they always ask us very detailed information like my name, how to spell it, and how to and the numbers. Okay, so I need to prepare all the stuff before I call a phone. call call the customer service. Very interesting experience. I hope everyone can try it once. Okay, next one. Statically determinate and statically indeterminate. Okay, structure. What does that mean? In Chinese, 静定静不定. Well, it doesn't mean anything. It doesn't mean anything. Well, but English is kind of understandable, which means that in the statical force diagram, you can determine what you want to determine. But if in this stuff, indeterminate, which means that you cannot determine what you want to determine. All right? Right. Let's see how it goes. If you cannot use statical force balance to determine what you want to determine, you need to use geometry relationship. All right. So that's it. Let me take a let me show you an example. There's a statically determinate bar P1 and P2 and R. So you can determine the the R. What is R? R equal to P1 equal to P1 plus P2, right? So the unknown here is R. Typically, we know the force we apply. So P1 and P2 we are known. Okay, so R is unknown. And then if you have extra fixation support or fix, which means that you may have more than one unknown, and sometimes you don't have enough static force information to be an equation. So you see, Fy equal to 0. In this case, you can obtain Rb. But Fy equal to 0, you have two unknown, but you only have one equation, which means that you cannot determine what you are going to determine, right? Ra, Rb. So this is called statically indeterminate structure. So when God closes a door for you, they will open a window for you, right? Okay. So how to solve this statically indeterminate structure? How to solve it? Ra, Rb, P. Okay. Again, we are going to cut it. We want to know the internal force in it. Okay. So we cut the first part and we cut the second part. And then, well, this is the Ra, right? This is the Rb, and this is P. And just for simplicity, all right? The upper part I cut, I leave the upper part. Okay, and lower part I leave lower part. All right, and this is Ra. Ra, and I don't know the N1, so I assume up. All right. Well, sorry. Can I just directly make it downward? It's because it's too easy. All right. You know N1 is downward. Okay. And RB. Sorry. I should make it with the same height. Okay. and this is RB, and this is NCB. NCB. All right, so balance. No, not balance. Sorry, issues. Force balance. Force balance. Grammar is bad. Sorry. So in the force balance equation, sigma Fy equal to 0, Ra minus P plus Rb equal to 0. They are two unknown. Not okay, right? So we need to introduce equation of compatibility. What is compatibility? Compatibility in Chinese is 相容性. Okay, so which means that you need to satisfy the boundary condition. Okay, because you have two extra fixed ceiling and the floor, right? So which means that it must introduce you a further equation, delta AB equal to 0. So in total, two sections summed up together, their total displacement should be 0 because it confined between ceiling and floor, and this distance won't change. Okay, so delta AC RA AEA, delta CB RB BEA minus. Well, this plus and minus purely depending on the balance force. All right, so maybe it's not minus. All right, in this case it is minus. All right, if the value you assign you will give you the hint. So delta AB equal to delta AC plus delta CB equal to 0. So you see, two equation, two unknown. You can solve that. So statically indeterminate structure cannot be solved by purely force balance equation. You need to introduce compatibility equation. Okay, I know this is a little bit just conceptual. I mean, just like conception. So I'll give you an example. You have two material. The first material is C or S. I don't know, maybe C is concrete, all right? Maybe, I don't know. S is steel, I don't know. So C and S, gray is C, blue is S. Material C property ACEC. Material S, ASES, all right? And then it compressed by a point load, and the point load acting on the dark blue material, or you can say this is rigid, or you can say it's glass. I don't know, but it's not important. Okay, this material is not important. It just tell you that this material, this blue plate, can convert the P into uniformly on the acting uniformly on the cross section. All right. So you can notice that it must compress with the same displacement. All right. S and C is undergone the same displacement. So it will act as compressive force for PS and PC, sigma S, sigma C, and total delta. Okay. So firstly, this is purely statically indeterminate because you have more than one material, but you have only one force. So what can you do? Firstly, a equation of equilibrium. All right. Sigma Fy equal to 0. So minus P plus, okay, you see, if you want to see the force in the material, you need to cut it, right? Cut it. If you cut it, you will leave like this. So you can imagine that the PS is what the steel or material S suffered. And PC is all kind of a circle, right? It's a circle. Sorry, I cannot make it like this. Okay, otherwise you can see anything. Okay, so this is kind of a circle force, PC. So you can see P downward and PS upward, and PC is kind of is a circle of the PC. So you see P is downward, PC and PS are upward. We assume that upward, okay? We just assume equal to 0. But you see, two unknown. We don't know. Okay? Is that breaking time? Sorry. Okay, so I will give you 10 minutes. Thank you. If you have any questions, just come here. Thank you.哦，PS 跟 PC，你可以想象就是 P 往下压，但是它到最后它一定是立平衡的状态，所以它会停在那边不动。所以 C 材料跟 S 材料会给它一个反力，让它抵消掉上的 P。那我们可以想象 PS 就是蓝色的它的 PC 就是那一圈挡住它的力，那所以这两个加在一起就看懂吗？谢谢。
讲他都讲他好像讲一大堆东西，但是讲的东西又好像没什么东西我讲回来。他后来开始，他让我觉得他是往前进，但留那就不在少了。每次他背后都我觉得是在上面这个，然后讲一讲会讲干，然后都知道，这个题来就，你觉得是一条道。还有这种催促这个事情，然后你就会让你思考，然后看出大概的，他说对，然后我就这个，哦对啊，哦，啊，我们现在到我就行，然后中完，中完之后，那做实在是有看，在干什么事？照顾别人，照顾好自己。所以那个是，那就不打着，你把你里面都开起来，那这是什么东西？当跟自己是什么东西？是哇，这个这个，我看都你在做啊，就是他后来不是那个运动，那第上失败了，他那个这个上海外是照这个跟这边的问题，政治这些毛病就是不要干，不要你那玩意儿挺差。然后我当主任不咋说自己嘛，要是我手都不动。啊，这个像我们那个东西，他们那个东西是吧？一下一对一就是了不起，听不着掉一个。这个东西上，然后他会经常跟他们突然上去，然后他会经常会哦，他这样子，所以我这讲的很细，把你完全包括生的东西，刚才是没这样子说是，你要讲这个讲这个。他们不像这个小镇，他们高兴不接受的是，那上一个我被为什么？那些少年人就是需要我讲什么？我刚开始他们从来就买自己的家，一个照片一样吧。就是那跟我讲，他是一模一样的东西，买自己的，那个去体检小不要去，他自己找来上面也是。最后我再讲看故事。然后他们只要认，然后是然后他们要去上去，然后他们在那那可能在这里写的，然后在这里然后让整个去的是还是跟大家来看，那我上是应该不是看不是慢的，然后那是在炒在上面上。我的基础思路上面会变，我的这个故事这个是往谁看？我们这个啊，可以，是他故事，那很多在说这个，自己要想， 刚好是那你可能现在刚好是他们考试的人，然后别人在因为你开过这个，现在的这个不会进去了，是吧？你确实不好意思，这关键是，那我会思考完全的东西。我想，我要想在天天放那个，但是一个是私立就是多少差不多，但是如果就是那一个就是想要的话是，就是一开始点有什么，那你上去写看是谁来看什么什么什么，然后写字都看没有办法做一样，但是做一些表示，哦，那有一些就开始了，然后那一次。在这个事，哦，那接着下是知道，他这个事情没有成立时就不去解决，实际然后他开始，就没有时间，需要物理下来的时候，你讲这个名字，我也是，我也是，因为是这个样子，但是人，我看到他没有问题的。
哦，时间到了。嗯，每次都觉得下课时间怎么过那么快？我可能有跟你分享过，就是我小时候觉得10分钟很长，然后但是现在觉得10分钟很短。我跟大家分享过嘛，就是总之就是我以前国中的时候，真实的发生事件哦，我国中的时候教室是4楼，然后我们一下课就冲去操场打篮球，然后打完球以后再跑回来，怎么会这样？你看我现在我只是去办公室背个包包，上了厕所，诶，就上课了，怎么可能呢？这怎么可能呢？怎么太奇怪了？然后我又想到另外一个，我最近我不知道有没有跟大家分享过，反正我每次分享东西，搞不好我分享过，对不起，有听过的人就不好意思一下，因为我太多课了，所以我不知道我有没有分享过。总之就是，你有没有发现？我觉得啦，搞不好人跟动物的感受是一生的时间是一样的，你知道我讲的吗？因为乌龟很慢，所以它可以活很长。但是狗啊、鸡啊、狗啊、鸟啊那些，它不就这样然后猫啊所以它只能活十几年而已。但是它在它心中，我们走路走，我们在他们眼中，我们走路可能是超慢的，然后就觉得我们像乌龟一样。但我们看乌龟，可能就觉得乌龟超慢的，然后他可能觉得我们的100米赛跑的那个 boat 哇跑超快，但是他觉得很慢这样。所以人类可以活70、80岁、80、90岁，嗯，所以可能猫跟狗，它是以我们4到5倍的速度在看这个世界，所以它活15年也蛮长的。那这时候你就会想，你不是曾经看到有一些影片说狗被放在家里嘛，一个人关在家里面，然后就在等主人回来嘛，然后他就在那边静静的坐在那边等着。哎，他等于花可能一整个岁数的时间在等我，哇，我觉得还蛮感人的啊。Anyway，这就是这样啊，讲完了。那有没有那种速度很快，但是寿命很长的呢？的动物啊，有没有？ 速度很快但是寿命很长的动物？鱼。大型鱼寿命很长，真的？但它很慢吧？不是。但它很快吗？有没有一个完全绝对，就是它超快，但是它又活得很久的动物？有没有一个没有任何的悬念？恐龙吗？我们不知道，恐龙平均岁数多少？应该也没有到70、80岁吧？蟑螂，它实际上也不快啦。蟑螂对，蟑螂平均岁数多少？我觉得它不一定，对嘛？不久啊，它不久啊，不久了。它虽然算快，好，我们这边的快应该是要比，就是说它的生长跟它的速度，这样好不好？比率，对。所以好像，难道我可以发 Science Nature？哎，真的吗？所以已经有被发表过了吗？哦，这当然啦，时间相对论，我们慢啊，对啊，对啊，我知道啊。但我的意思说跟寿命，就是平均寿命这件事情，就非意外性来讲，就你人类跟动物的感知，对，这个关系是不是差不多？这样的意思？鸟啊，就这样很快啊，你看它头都这样，然后我们转是这样转，它是这样转，你看我们哪受得了？所以搞不好我们用这样子的方式去活，我们就会短命。没有，就这样，对不对？对不对？就是这样啊。啊，哇，这个东西要讲的英文很难呢。好，算了，我不想翻译了，再见，开始上课。So now let's talk about the continue. Okay, so sorry I didn't say because the time is finished for the break time, so I didn't talk too much. So okay, so I will talk about this like again. All right. So if I want to know the internal force in the materials, we just cut it, right? And then I can either choose up, leave that up, or leave the bottom part. So here is leaving upper part. Okay, upper part is that if I leave upper part, P go downward. So which means that the C and S must against the P. So the PC is up, PS is up, no problem. And then if we really want to know the material is under compression or tensile, so we can see the opposite part. If this is up, it must be down in the opposite side. And if this is up, it must be opposite side. All right. So we know that this material is under compression, but for the material up part, in the upper part of the material, it will generating the opposite side of the direction of the force, upper PC, upper PS, and against the downward P. So this figure is for here, not for this. All right, because in this part we cannot see P. Okay, because we cut it. All right. So firstly, equation of equilibrium done. Next one, equation of compatibility. Okay. So what is the compatibility? Is that equal to 0? Delta equal to 0? No. So we cannot memorize this. We cannot memorize this. This compatibility equation is based on the boundary condition. So what is the boundary condition here? Because two materials compressed by the same cap, okay? So their displacement should be the same. So delta S and delta C need to be equal, okay? Then equation of constitutive, which in Chinese, but go, it doesn't sound mean anything. Well, constitutive means the fundamental rule. So you understand the constitutive law, okay, of a 宪法, okay, in the US constituted. And in the mechanics, the constitutive means stress, strain, relationship. All right? So 本构方程式 constitutive equation means stress and strain relationship or stress strain equation. So now you know that how can we get this? Delta S equal to L divided by ESAS, and delta C equal to PCL and ECAC. So you can see that it's sort of, maybe you will ask, hey, this is displacement and force. Force and A is stress. Delta S and the L is strain. So this is stress-strain relationship. All right, constitutive equation. So now we have equation 1, equation 2, equation 3, and from 2 and 3, you can have PSL divided by ESAS equal to PCL ECAC. Okay? Now, you sort of get the relationship of PS and PC. So now, the first one, what is PS and PC compression? PS plus PS ECAC. Well, we substitute the PC by PS. ESAS equal to P. So the PS equal to P divided by a little bit ugly plus ECAC ESAS. So PS equal to ECAC ESAS plus ECAC. Okay. How about PC? So you can substitute a PS back to the equation of equilibrium to get a PC. How about I can do some trick? Hey. So this is, sorry, this is PS. Okay, this is the PS. And this is ECAC. Okay, that's it. So you can obtain PC and PS. All right. And suppose the P is known, okay, because this is the load you apply, and EC, AC, ES, AS, ES, they are all given by the problem, okay. So this is the first equation. First part of the problem. The second part of problem, sigma S, easy. PS divided by AS. Okay, you can divide by yourself, all right, easy. And delta C equal to PC divided by AC, no problem. And the third one, delta. All we need to do is just determine one of them. Delta equal to PSL divided by ESAS, or you can learn, you can substitute them as ESAS plus ECAC. Okay, because PS is this one, right? So we substitute that into here, and you can get a relatively simpler form. All right. So you can notice that the most important concept is in this problem is how we use equilibrium equation, compatibility equation, and constitutive equation. Okay. And then another point thing is that the equation of compatibility, you should manage that by the problem's boundary condition. You cannot memorize it, okay, because boundary condition varies problems from problems. All right, they are changing, so be careful. Okay. So I hope you can, but the concepts are all the same. If you want to see the force, you just cut it. Okay, just cut it, separate them, and do the equilibrium equation. That's it. Next one, I'll give you some time for taking notes.我就在想啊，就是那种我蛮喜欢看那种 stand up comedy，就是站在台上讲话，就一个人在上来讲话就可以让大家笑，这样我觉得我很佩服这种人。那我也蛮希望就是说，如果这些人可以当老师，他们学生一定学得很好嘛，对不对？所以在想说，哎，有没有机会？结果我发现有一位老师真的这样做，你知不知道？大家知道吗？大家知道我们交大有一位老师真的去讲comedian吗？对，阿泰老师，对对对，你有看过他的现场吗？你有看他的 YouTube 吗？有，真的啊。对啊，我觉得好酷哦，真的很难哎。因为当那个东西表示说你跟别人说，哎，我要讲笑话咯，通常你这样讲笑话，别人就不会笑，对不对？所以真的还蛮难的。然后最近我蛮喜欢的一个是 Jimmy O 一样，是不是？有听过吗？没有，赶快去搜寻啊，好笑，好笑。他是一个港裔的美国人，都没听过吗？Jimmy O 一样，真的？还是因为他推播我？不对啊，他最近蛮红的啊。好了，anyway，去查一下，我觉得他蛮好笑的。好，下一个。I just recommend Jimmy O Yang for the stand-up comedian. Yes. All right. The next one is there's a blue bar, and which is rigid. Okay, ADFBR, rigid bar. All right. And which means that this bar is rigid, will never deformed. Okay. And B has a force P. So now there are many stuff here. E1, D1, L1, E2, D2, L2. Okay, E1, L1. So two material. All right, two materials, CD and EF. So they gave us the material properties. D2, L2. Okay, so sigma 1 allow, sigma 2 allow. Okay, so the material 1 has the sigma 1 allowable, which means that the material cannot exceed 200 micropart, 200 megapart, and sigma 2 cannot exceed 175 megapart. All right, so obtain formula of P. Substitute both data. All right. Okay. So anyway, just calculate the formula of the P by using symbol X or Y or L1, L2. Okay. And this is B, B, B. Now, again, this A here, we don't know the reaction force, right? So the pin will fix, like my fingers, fix the bar. So which means that you cannot go up, you cannot go left or right. So which means that there must be a vertical reaction and horizontal reaction. All right. And we don't know the direction, so we just assume up and right. And again, P is here. However, if we want to determine the force equilibrium for the blue bar, we need to, and we don't know the CD and EF, right? So we want to know the force in CD and EF. So we cut here. Okay, and then we leave the bottom column. So the L1, L2 has a tension T1 and T2. Okay, again, we don't know the direction. We will assume up. All right. So these things, these forces need to be balanced. So firstly, RH, because there's no horizontal force, so RH equal to 0, no problem, right? And equilibrium, equilibrium of equation of equilibrium, equilibrium. Okay. So firstly, we need to obtain the T1 and T2. Wow. So let's take a look. Sigma MA equal to 0. So T1B, well, T1B, if we make the A as the origin, T1 about rotates counterclockwise about the origin. So this is positive. T2 counterclockwise, positive. P is clockwise, so P will be negative. So T1B plus T2, 2B with the force arm doubled, minus P triple B equal to 0. All right. So your T1 plus 2T2 equal to 3P. You see, only one equation, but you have two unknown. The next part, B equation of compatibility. So compatibility depending on the geometry. So what is geometry? ADFBR geometry, right? So it changed, it doesn't deform. So delta 1 and delta 2 must satisfy this straight line because it's not deformed, right? So delta 1 and delta 2 must satisfy similar triangle here. Okay, so it's relatively easy, right? Okay, relatively easy. 2 delta 1 equal to delta 2 because AD and DF, the length are all BB, right? So 2 delta 1 equal to delta 2. C, equation of constitutive. Okay, relationship, that's okay. Relationship, okay. Delta 1 equal to, okay, T1 L1 over E1 A1, okay? And delta 2 equal to T2 L2 E2 A2. And because this is too big, too complicated, all right? So may I using some simplification, all right? Simplification equal to F1 T1 equal to F2 T2. The F is just a fraction. It's a ratio or coefficient, all right? To save some space, F2 T2 equal to F2 2 F1 T1, okay? Yeah, so the T1 equal to 3F2P divided by 4F1 plus F2. And T2 equal to 6F1P 4F1 plus F2. Okay, here I would like to give you some sense of this course. Okay, sense. You need to have sense. See, T1 and T2. You see the how it looks like. Okay, you see 4F1 F2 4F1 F2. So it looks very similar. They have the same base, and F2 F1 P P. And this is 3 and 6. So it kind of makes sense. Symmetry. Okay, if you calculate that 3FP A or B here, and this is nothing here, it must be wrong. Okay, so you need to have a sense because they are the same level of things. Okay, so their shape should look the same. Okay, I believe you understand what I'm talking about. All right, so we are ready. T1 and T2. The T1 and T2 can be obtained by the constitutive relationship, right? 1. Sigma 1 equal to T1 divided by A1. Okay, so 3P divided by A1. F2 divided by 4F1 plus F2. Okay, sigma 2 T2 A2. Okay, and the P here equal to sigma 1 A1 4 FA1 plus F2. And 3 F2. Okay, and you may have different P2 sigma 2 A2 4F1 plus F2. Okay, and 6F1. All right, so you notice that okay, so you have T1 and A1, T2 and A2, and then you can determine the you have the formulation, so you can have the P here. Okay, so this P is obtained from sigma 1, and this P is obtained from sigma 2. Okay, right. So there will be two, I mean, okay, if you have one value of P, okay, and you substitute this P, and you can determine the sigma 1, sigma 2. And then if you want to know the sigma 1 allowable, sigma 2 allowable, which means that if you substitute sigma 1 allowable here, you can obtain the P, which is the maxima to preventing the T1, I mean the material one not break. Okay, if you substitute sigma 2 here, you can obtain the P for the maxima that the material 2 not break, but exceed one of them, it will break. So now you have the P, the two formation of P. So the obtained formula of P, well, you have two equations, but when you substitute above data, substitute the number numerical data, and then the what sorry, the greater or the smaller one is the answer. MSP. Yes, you are right. Exactly. Yes. Thank you very much. So the smaller one is the answer of P. All right. Thank you for your. But I should ask everyone, so let everyone should have a chance. All right. So how can you give me the number? 1113. Oh. 6139. Okay. Good. Next time I should give you the one chance. If you cannot pronounce your number right, I will give the chance to others. So 112, sorry. 613. Okay. What? 3039. Wow.
Erase the 3 behind the third.
1113 613039.
The fourth one. Erase it.
Oh.
Yes.
Eh.
Yes.
All right. Very difficult. So when you are on the phone, talk with a foreigner, the customer service man or woman will hate you. So they will become yeah. So every time I call my customer service, I always sweat a lot because I'm really nervous. All right. sometimes you will encounter a really a customer service officer that was very less patient. Okay, so to prevent this, I always prepare a lot of information in hands. So everyone, if you want to get a bonus, you should prepare your number and yeah, memorize it. So next time, how about that? Next time I will give you only one chance. You shouldn't correct. I will give you others chance. I don't know why. Anyway. Good. Thermal effect. Thermal effect. Thermal effect is really important for material science engineering, right? You know that as the temperature change, the material will expand or contract. Okay? This is common sense. Producing thermal stress or thermal strain. Okay, it's a little bit misleading. Okay? You see, producing thermal stress or, which means that it's not simultaneously, well, it can happen, only occur one of them, all right? It can only occur one of them, all right? Of course, it can occur simultaneously in a very complicated system, but I'm saying that you may have thermal stress free, but you have thermal strain, okay? Let me explain to you. Thermal strain means that epsilon T, the strain due to the increasing or decreasing of temperature. And this is alpha times delta. I believe you understand this. Alpha is coefficient of thermal expansion. Sometimes we call it CTE, thermal of E expansion. All right, CTE. Okay. Typically greater than 0, of course. You rarely heard of the material increase the temperature and contrast. It's quite a bit weird. Then elongation, of course, delta T epsilon T times L. Okay, no problem, easy. So you can easily understand thermal strain, no problem. How about thermal stress? Thermal stress typically induced by statically indeterminate structure. Why? You can see that if the stress, if the material is here, and you increase the temperature, and both of them elongate, okay, become longer, and it will shift to, certain precision, and both of them increase the length, but successfully. So they have thermal strain, but the state is stress-free. No stress inside this, no thermal stress. But if you fix it, it become, if you don't have this fixed C and D, you will end up, if you don't have a C and D component to fix it, okay, it will end up like this. If it end up like this, it has stress-free, no thermal stress. But if you fix it, it cannot go expand as it like. It will has thermal stress. All right. So thermal stress and thermal strain are not necessarily occur together, but they can occur together if you have a complicated material system. Okay, but for a simple system, material system, you can see that sometimes they don't have the thermal stress, but they have thermal strain. So now this is quite classical problems. All right. So now we have RA and RB, sorry, two walls confine a bar between each other. And it increased the delta T, temperature change delta T. Find the sigma T, you see? Because it cannot elongate as it wish. So it will induce the stress inside, okay? Yeah, so for example, if you want to do something and your parents or your teacher or your professor don't allow you to do that, and you feel stress inside, okay? Fifth, very similar. All right, so if you have a two walls, it will give you reaction force, RA and RB. We don't know the direction, right? RB, we just assume that it's go to the right hand side, positive direction. Here, A, equilibrium equation, equilibrium, okay? Sigma Fy equal to 0. So RA plus RB equal to 0. So which means that 9 minus RA equal to RB. So which means that one of the direction is wrong. Okay, one of direction is wrong, but I don't know. Okay, we don't know, but it's okay. Just leave that. Second one, equation of compatibility. Okay, right. So now this is a little bit tricky here. I need you to pay attention on this. Now, if you increase the temperature, if you don't have the wall B here, if you increase the temperature, it should elongate like this, right? So it should have a delta T to the right hand side. Okay. But the thing is, the real case is that it is not elongate that time. It not elongate like this, right? The reason why the RB push it back. Okay, so which means that the RB push it back, but don't forget, we assume RB to the right hand side. Okay, so RB is still going to the right hand side. You need to stick to your to assumption. You cannot say, oh, here obviously it's go to left, so you plot left. No. You assume that to the right. You need to stick to your assumption. You cannot vary by your emotion. Okay, although you know that it's not correct. Okay. So our equation of compatibility is delta T. Oh, by the way, the RB will cause delta B. Okay, the RB is the force. If you don't have the wall, but you have RB, okay, RB will make the delta B here. So delta B and delta T should be summed up together as 0. Because they all go to the right hand side. Okay, although you know this is something, I mean, that you know your assumption is incorrect, but you need to stick to your assumption. This is the most important thing. Okay, so what is delta T? Alpha delta T L, no problem. Delta B is RBL divided by EA. Well, sorry, I didn't write down the C equation of constituted law. Okay, sorry. But here is I'm substituted constituted law into the delta B. So this is constituted. Okay, I don't want to write it down now because I believe you know what I'm talking about. So your RB equal to minus EA alpha delta T. So you see your delta T here. You don't know delta T is positive or negative, right? But we assume that positive, so it elongate, right? So your delta T assume the positive, right? You assume increasing temperature. So everything we assume that positive direction. Delta T positive elongate, and RB right hand side elongate. But then both of the delta T, delta B sum down together should be 0. So your RB will be negative EA alpha delta T. So this is important. So delta T, if the delta T is positive, increasing temperature, your RB is in the negative, in the other direction. Okay? But if the delta T is minus, which means that your RB is going to the right hand side. Okay? So sigma T equal to RB divided by A. So it's minus E alpha delta T. So this is really classic. And I really like that, although this looks a little bit, stupid, it doesn't make sense, but you still need to stick to your assumption, and then everything will, correct systematically. 听得懂吗？即使是你知道这个有点假设绝对是错的，因为你知道它会推回来，但是你已经假设它往右走了，你就得持续保持下去。你看这边其实还蛮怪的，对不对 ？Delta T 跟 Delta B 明明应该就是减啊，但是不行啦。如果你直接这边写减的话，你就等于是打自己的脸。你的 RB 你是假设正的、往右走，对不对？所以你的 RB 往右走，然后你的 Delta T， 当然了，这 Delta T 你也是因为你的假设它是正的，就是增温这样子。所以你要想想看，如果今天是降温的话，你如果是降温，这边 Delta T 是负的话，你的 RB 负得正哦，所以表示说 RB 真的是往右，然后你的 RA 就会是往左 ，OK？ 因为你已经知道 RA 跟 RB 是相反方向，所以这边只是告诉你 RA 跟 RB 之间绝对是相反方向，但是在这一个地方，你就可以告诉你的假设到底是正确还是错误。那端看你的 Delta T 是正还是负的，哦，这边还蛮重要的，蛮经典的一题的。Okay, next one. Next one is even more difficult. Okay, you have two materials and with the bolt head on the top. Bolt head. Okay, and this is S. This is B. What is S and B? The S is sleeve. Wow. You learn vocabulary in mechanics of materials. Sleeve, right? 袖套. So again, the temperature, delta T. Again, it doesn't tell you increase temperature or decrease temperature, but don't worry, we just assume positive, okay? And alpha S and alpha B, alpha S greater than alpha B. So you can imagine that alpha S can has longer elongation for the same value. Now, it need to find delta S, sigma S, sigma B, and increase delta in the length L. So of course this is L, okay? L. Okay. So very important. Just like what we did before, we assume that there's no bolt head, no fix. What will it be? And then you need to push it back. Okay, so now this is the original length. Okay, and then if you don't have the head, you don't have both head, no constraint, you increase the temperature. The delta 1 will elongate further and much. And the boat will increase a little bit. Okay, so you can say this is delta 1 and this is delta 2. Okay, finished, right? All right, so I will continue this lecture tomorrow at 9 p.m. 9 a.m. Sorry, 9 a.m. All right, so thank you. If you have any questions, just come here. Bye bye.